Here we have a problem on finding domain and range of a composite function, that is f dot g, where f of x equals to e to the x to the power and g of x equals to x square. Okay, to find the domain and range of a composite function, first we have to write the composite function using the formula, that is f of g of x. So whenever I want to do a composition of two functions f and g, so its formula is f of g of x. Okay, in this composite function, first I have to know which is first function and which is second function. Okay, so there are two functions, one is f and other one is g. So how do we have to know which one is first and which one is second? So for that, just look at the stuff over here. So in the given two functions f and g, for which function can we give input at first? So here in the composition of two functions, g of x is clearly seen. So we can give input for g of x at first. So since we can give input for g of x at first, this g of x, this function can be considered as a first function. Let me write it. And the other one, this f has to be considered as second function. Let me write it. Okay, now let's start finding the domain of the composite function. Usually, what is domain? So for example, to understand domain, let me consider the one of the given two functions, that is g of x equal to x square. Okay, in this function g of x equal to x square, so what are the possible values of x? That is, we have to find the values of x for which the function g of x is defined. So we can plug in any real value for x over here. So for any real value of x, the function g of x is defined. So the domain is all real values. So domain is a set of values of x for which the given function is defined. Okay, now to get the domain of a composite function, what I have to do is I have to get the domain of the first function. So in this case, g of x is the first function. So I have to write the domain of the first function, that is g of x, that is the domain of g of x equals to. So just now we discussed the domain of the function g of x, that is the domain of the function g of x is the set of values of x for which g of x is defined. So here g of x is defined for all real values of x, because here in x square, so if I plug in any real value for x, it will be getting a defined value for x square. So the domain of g of x is all real values. So usually the domain of a composite function is the same as the domain of the first function. In this case, it's or. Otherwise, the domain of the composite function must lie inside the domain of the first function. That is, the domain of the composite function has to be a subset of the set of all real numbers. So what do we have to do now? So for that, we have to get the result of the composition of the two functions, that is f of g of x. Okay, now let's get the result of this one, that is f of, let me write it over here. Okay, for g of x, already we know the stuff, that is x square, so we can plug in x square for the g of x over here, then I'm getting f of x square. Okay, we know that f of x equals to e to the x to power. So if I want to get the stuff f of x square, I just have to plug in x square for the x over here, then I'm getting e to the power of x square. So this is the result of the composite function. Okay, now what is the domain of the result of this composite function? What values can we plug in for x over here so that the value of e to the power of x square will be defined? So for any real value of x, there is e to the power of x square will be defined. So the domain of this, the result of the composite function is also all real numbers. So for the domain of the result of the composite function, we got all real numbers. The domain of the first function g of x is also all real numbers. So how do you have to come to the domain for the composite function? So for that, let me draw a real number line which represents the domain. So let me write positive infinity, the right side extreme, the left side extreme is a negative infinity. Okay, so now first let me graph the domain of the result of the composite function, that is all real numbers. Since all real numbers are domain of the result of the composite function, so I have to sketch the entire part. Okay, now let me graph the domain of the first function g of x, that is also all real numbers, and we have to graph for the entire interval. So now what is the common region for these two graphs? So which give the domain of the result of the composite function and domain of the first function. So the common region is the entire interval is a common region. So the common region of these two graphs will give the domain of the composite function. So the common region is all real numbers. Therefore, the domain of the given composite function f dot g is all real numbers. Okay, now we have finished finding domain of the given composite function. Okay, now let me erase some stuff and continue with the range of the given composite function. Okay, now let's find the range of the given composite function. First, let's understand what is range. So for example, let me consider one of the given two function, that is f of x equals to e to the power of x. So what is its range? Actually, the range is the values of the function f of x, or the range is the values we get for e to the x power, because this is a stuff equivalent to f of x. So now we understand what is range, but now our aim is to find the range of the composite function. Whenever I want to find the range of a composite function, first I have to write the range of the second function. In this case, it's f. Okay, now let me write the range of the second function, that is f of x. So the range of the second function. So how do you have to find the range of the second function, that is f of x equal to e to the x power? So like we know that e is a mathematical constant. Its value is approximately 2.71828 to the x power. Okay, so here whatever real value I plug in for x over here, so there is no chance for this value to become negative because it's positive sign over there. Even if I take x equals to negative value, or like something like if I take x equals to -1, then this e to the x power will become e to the negative first power, then it will become 1 over e. Still it becomes positive. Anyways, the value will become smaller because the value of e is 2.71828. So whenever the denominator is greater than the numerator, the value will be less than 1. So when I take a larger negative value as exponent over here, so the value of this e to the x power will be too small. It will approach 0. So for a very large value, that is, for example, if I take x equals to negative infinity, then it will be 1 over e to the power of positive infinity. So like infinity is a very large positive value, and where p is 2.71828. So for a value greater than, for a positive value greater than 1, when I take a very large positive value, again it will become a very large positive value. When I divide 1 by a very large positive value, it will become 0. So anyways, when x approaches negative infinity, there is a very large negative value. This e to the x power approaches 0. What if x approaches a very large positive value? So this e to the power x will approach a very large positive value. So the range of this one is going to be between 0 and positive infinity. So like we cannot input 0 here, because when x approaches negative infinity, only this value will approach 0. So now I got the range of the second function f of x, that is 0 comma positive infinity. Okay, now usually the range of a composite function is the same as the range of the second function that we got over here. Otherwise, the range of the composite function must lie inside the range of the second function. That is, the range of the composite function can be a subset of this interval. Okay, so for that, what we have to do is let's find the range of the result of the composite function. So here the result of the composite function is e to the power x square. So what is its range? So here, whatever real value I take for x in this one, always this one will be positive. It will never become negative because of the square. Even if I take x equals to -1, so what will happen? So e to the power of this negative on the whole square will become just positive 1. Then e to the first power is just c. Its value is 2.7828. If I take even larger negative values, this e to the power of x square will become larger value, because always it's positive. So like when I take x square as 0, like e to the 0th power, then its value will become just 1. So when x equals to 0, it will become 1. So other than 0, if I take any value for x, always it is positive. When the exponent is positive, always is e to the power of x square will be greater than 1. So the least value of this e to the power of x square is 1. That we get it when x equals to 0. For any other value of x, so the value of this e to the power of x square is greater than 1. So the range of the result of this composite function is 1 comma positive infinity. So for any large positive value or large negative value, this x square will become positive. Since the value of e is greater than 1, so when x approaches a very large negative value or positive value, so the value of this e to the power of x square will approach a positive infinity, a very large positive value. Okay, now I got the range of the composite function, that is 1 comma positive infinity, where 1 is included, and also we got the range of the second function f of x, that is 0 comma positive infinity. As I said earlier, usually the range of a composite function is the same as the range of the second function, that is 0 comma positive infinity, or the range of the composite function must lie inside the range of the second function. So now how do you have to conclude this one? So for that, let me draw a number line which represents a range. Okay, now let me take the right side extreme, that's positive infinity, left side extreme, it's negative infinity. So here in this one, I get 1 over here, number 1, and in this one, I'm getting number 0. So let me mark these two numbers over here on the number line 0, 1. Okay, now first let me draw the range of the result of the composite function, that is 1 comma positive infinity, where 1 is included. Since 1 is included, what I have to do is I have to draw a filled circle at 1, and so since we have 1 comma positive infinity, I have to move to the right up to positive infinity. Okay, now let me draw the range of the second function f of x, that is 0 comma positive infinity. So here 0 is not included. Since 0 is not included, I have to take an empty circle at 0, and since it's 0 comma positive infinity, again I have to move to the right up to positive infinity. Okay, now what I have to do is I have to find the common region of these two graphs. The common region of these two graphs is clearly this part. So the common region of these two graphs will give the range of the composite function f dot g. So the common region gives the interval 1 comma positive infinity. So therefore this is the range of the composite function f dot g. Okay, let me write that over here. So range of the composite function f dot g is 1 comma positive infinity, or it can be written as 1 less than or equal to y less than positive infinity. Usually to represent a range, we use the alphabet y.